Hey gang, so let's look at exponential functions in our pre-test video. Grab a dry erase board marker and a rag, or just sit back and watch. Either way, here we go. Alright, so we're going to start off with our first one, and we're going to write an inequality to represent the range. So take a second and look at it. And notice some things on here that most of you probably already know. Range is the same thing as the y values. How tall is it? So I need to look on here and I need to say, where does this range start? Well, I'm looking at the y-axis. So I'm going to look and I'm going to say, okay, it starts right there. Wonder what that amount is. Looks like it's going up maybe by 50s, except for that very first one. So I'm going to say that right here is about 250. So it looks like my graph starts at 250 and then it continues up all the way. So I need to say that my y values are always, what? 250 is where they start, and they're always bigger than 250. Does it actually equal 250? Absolutely it does. Now, remember, I know some of you like to put the boundaries on each end. This is positive infinity up here. Some of you like to say that we start at 250 and we go up to infinity. Y is in the middle. It's less than or equal to and less than. Either way you want to write it, I'm good with that as long as you understand. On this one, it starts at 250 and it continues up. This is the answer you would want to look for. Now, in words, can I write this in words? Yeah, and remember, we're going to do that a lot on this test. It's going to be multiple choice. You're going to see a lot of verbiage, a lot of words. So I could say it's all y values greater, I'm writing pretty fast here, than 250. But I would need to have or equal to. Pardon me. So anyway, all y values greater than or equal to 250. All right. If you have any questions and we're doing this together, raise your hand and ask. Otherwise, maybe jot your question down. Going on to the next one. F of x equals 2x minus 2. What is the domain and the range of this function? Well, here's what I would do. If I got this one on a test, I would take the function and I would put it in my y equals. And when I did that, I would go, okay, let me look at the graph of this. And the graph of this one is going to look something like this. If you were to graph it on your calculator. And it would look like that. And then you would see that right here is the asymptote. Now, it's not going to draw the asymptote on there, but that's what it would look like. And that's enough information with the asymptote, without the asymptote, to figure out what the domain and range is. Okay, let's look at domain. So the domain is how wide is it? Domain is my x. What is x doing? Well, here's my x-axis. I'm noticing an arrow going forever to the right and an arrow going forever to the left. There is absolutely no boundaries. If I were to put this in my calculator and go to second table and then scroll up the x values, there would be no x value that I don't equal. It's pretty much whatever x value I want it to be. It's going to be there. So if there's no boundaries, it's all real numbers. If you like to do the negative infinity less than x less than positive infinity, that's fine too. All right. The arrows give it away for the domain. Let's look at the range. So on the range, I look for a floor or a ceiling. And one thing I notice is that my graph is up here in quadrant 1. It's over here. It's actually not over here in quadrant 2, is it? It is down here in quadrant 3. And it's got a little piece down here in quadrant 4. That doesn't really help me. I do notice this asymptote right here. It looks like it's at y equals -2. And remember, we talked about this. The number on the end tells you what the asymptote is. So it's -2. It's going up this way for forever. It comes down here. Does it ever touch -2? No, it's playing the I'm not touching you game. So it comes down here to -2, and it goes up here to positive infinity. So how I would write that is that the range is always greater than -2. Does it actually equal -2? No, it never actually touches -2. It plays the I'm not touching you game, and it never touches it. So keep that in mind. When you graph it, look for those arrows on the end, because that means it goes for forever. And that'll help you figure out, oh, the domain is all real numbers. All right. Which graph shows an exponential growth function and an asymptote at y equals 3? I'm going to give you a second to do that. I'll throw some A, B, and C up here. Okay, so when I look at these, I'm like, okay, which one's not even exponential growth? Because that's my key word there. And I'm looking and I'm thinking, oh yeah, I see it. C is exponential decay. It starts tall, and goes low. So this is decay. So I'm not even going to look at that one. So it's between these other two. Well, what about B? Can I mark B off? Isn't B decay as well? Oh, hopefully you're like, no, Miss Dean, that one's a growing one too. This is a growing one. It's pretty easy to see it. But where's the asymptote? Yeah, the asymptote is way down here at the 0 line. Huh. That must mean it's B. Let me explain it. When you start low, when you start low and grow bigger, even though you're growing in a negative fashion, that's still an exponential growth. The asymptote's up here at 3, so yeah, it is B. So if I ask you for an exponential growth or an exponential decay, remember to always look and pay attention to what's it doing. Is it growing or decaying? Maybe I can eliminate some of my answer choices by the ones that are not decay or are not growth, whichever one I happen to be looking for. All right. The population of a town is 250 and is growing at a rate of 5% each year. Write an exponential function to represent the situation. There we go. Y equals AB to the x power. What does A represent again? A is the starting amount. What's my starting amount? Yeah. Let me write that down. So Y equals, my starting amount is 250 people. And what am I doing? What's the key word in this? Growing. So, in my class, I know I do it a little different than some of the others, but in my class, if you're growing, you're always 100. You always start at 100. And then if we're growing, we add. Okay? So if we're adding, we're going to look and we're going to find, what are we adding to? Oh, yeah, it's that percent. So that means I'm growing at 105%. But I can't put a percent back into my equation. I have to change it to a decimal. So it would be 1.05. Those of you that don't do it my way, that's fine. As you watch this, just make sure you got the 1.05 to the x power. Write an exponential function to represent the situation. Now, what if I asked you, when will the population of the town be 500? How would I figure that out? I don't have a calculator on here to show you, but you would go to your y equals button on your calculator, plug in the formula. This is your population, 250. You want to know when will that be 500. So go down your y column, figure out when it's 500. You do not, just for the record, put 500 in the x. Don't do that. No. You're trying to figure out when is the population going to be 500. Okay, we're doing pretty good on time. We're hanging out at 9 minutes. What does the A represent in this function? Just in general, what does A represent? Hopefully you're thinking. It's the starting amount, yes. Also known as, what else does it represent? If I'm graphing, it is the y-intercept, yes. Hopefully you said that. So, A is the starting amount or the y-intercept. Remember that. Okay, here's a fun one. Take a second, look at it. I've got a graph, and this graph is growing or decaying? Yeah, growing. I tend to always do growth. I'm kind of noticing that. I see my y-intercept. It looks like it's going up a couple thousand each time, 5, 10, 15, 20, 25 on the bottom. And then it gives me a chart over here, and it says time and population. 0, so you see 0, 5, 10, 15. What does the y-intercept represent? So let's look at it. Here's the y-intercept right here. And it looks like if I look over here, it must be at 2,500. What does that represent? Looking at my table right here, what does that 2,500 represent? Yeah, hopefully you said the population when? At the start. That is the key phrase, at the start. Whatever this problem is, I have no idea. But I know that at time 0, the population is 2,500. So that means at the start of time, whenever this whatever started, the population was 2,500. All right, and I think that, yep, that concludes it for my on level. You guys are good to go take your test. Good luck. Honors, keep watching. Just a couple of reminders. We did the quiz on this. Linear, exponential, or other. Remember, please use your calculator. Please put these into your calculator. Hit graph so that you can see what they are. 2x plus 1 is a whole lot like y equals mx plus b. That would be linear. If x is the exponent, it is exponential. X is the exponent, it is exponential. Oh, this has a 2 up here. If you were to put that in your calculator and graph it, it would look something like this. That would not be exponential, that would not be linear, that would be an other. All right, one last thing, just want to remind you, not a lot of it on the test, but in behavior, how does x and y behave? As x approaches positive infinity, y, I'm going to look, as x gets bigger, the y goes up, so y approaches positive infinity. As x goes to negative infinity, the graph comes down, and the y value is getting smaller and smaller and smaller, so y is approaching 0. I don't have much end behavior on the test. I just wanted to be sure you remember it. You are good to go, honors. Have a great test.